Okay, so greetings everyone. I am Chard here, and I am the one tasked to teach every one of you one of the Vedic mathematics applications, which is one of the most important, which is vertically and crosswise multiplication. Again, welcome to the 8th Online Vedic Maths Conference. So this workshop of mine will have these course content. We're going to have vertical and crosswise multiplication, and we're going to apply at the latter part this vertical and crosswise multiplication to multiplying algebra or multiplying algebraic products. When all from 9 and the last from 10 sutra, multiplication sutra or method itself, it's one of the specialized method and in Vedic mathematics, making use of this sutra. If it is not feasible to be used, then we use the sutra Udvatigrayam. In Sanskrit, we have this script, and English that is vertically and crosswise. Here, what we will do is we will learn to multiply 2 by 2 digits, 3 by 3 digits, and etc. in a one-line fashion. As much as possible, we're going to do it in a one-line fashion. I'm going to show you how. How do we apply the vertical and crosswise multiplication in multiplying 2-digit numbers first? So this is the basic, and we will build on this process and see how we continue with the 3-digit numbers and 4-digit numbers and so on. And this is how we do it. First, since the sutra is named vertical and crosswise, what we're going to do is first vertically, we multiply left. Anyways, we're going to multiply from left to right. That's the common way of multiplying Vedic mathematics, since usually and we read mathematical numbers or numbers from left to right. So if we can find a way to to operate multiplication from left to right, so if we're going to use this in our everyday work, it's like when we are reading it, we can actually do the operations themselves, since we are reading from left to right. But usually in schools, we teach multiplication or addition or any operation from right to left. So if we can read it from left to right and multiply or add them in left to right, so while you're reading, you can operate already. So this is the steps. First is vertical. We're going to multiply tens digit by tens digit. So from here going here, the sum or the product here will be the hundreds place. Then we will multiply crosswise the tenth digit of the first number and the ones digit of the second number. We add that product, and then we add that to the product of the first digit or the ones digit of the first number by the tens digit of the second number. So we add that, we sum them up, the products, then that will be our tens place. Seldom there will be some carry-ons that we need to use right after this method. And then lastly, we will multiply, and again, vertical, from ones digit and ones digit. That is step 3. And I'm going to show you how, making use of this first example of ours, which is 21 times 23. So how do we do this? So let us first set this up like this, 21 times 23. And then we will multiply vertically first by this step 1. 2 times 2 is going to give us 4. That's going to be our hundredths place. And then 2 times 3 is 6. So this is going to be 6 plus 1 times 2, which is 2. So 2 plus 6 is going to give us 8, which will be set as our tenth digit. And 1 times 3 is 3. Now that's the product, everybody, for 21 times 23, 483. Okay, and notice it is presented in a one-line fashion. All right, and we're doing it from left to right. Another example for everyone, we have 26 times 11. So how do we do that? First, vertically, 2 times 1 is going to give us 2. And then crosswise, 2 times 1 is 2. 6 times 1 is 6. 2 plus 6 is going to give us 8. And then 6 plus 1 is going to give us, 6 times 1, is 6. So 286. If you know the shortcut, or there's another Vedic method when you multiply things by 11. So if one of the factors is 11, so you just add these two numbers, and then that will be the tens digit. So but the thing is, this method is general, so it can be used in any 2-digit numbers. As long as you're multiplying 2-digit numbers, this can be applied. Okay, More examples. Okay, 42 times 13. Let's write it here. 42 times 13. So 4 times 1 is 4. 4 times 3 is 12. We're going to add that to the product of 2 times 1, which is 2. So notice 12 plus 2 is 14. We're going to carry 1 to the hundredths place. And then 2 times 3 is 6. So we can fix this by making this 5, 4, 6. So 42 times 13 is 5, 4, 6. All right. So that's how easy it's going to be. Next is 59 times 17. Okay, more practice. 5 times 1 is 5. Okay, 5 times 7 is 35. Let's write that down. Add that to the product of 9 times 1, which is 9. And then 35 plus 9 is going to give us 44. And then 9 times 7 is going to give us 63. So that gives us a 5 plus 4 is 9. But notice in the tens digit, we need to round it up to 10. So 9, we're going to add 1 there. That's going to become 10. This is 0 and then 3. So 59 times 17 is 1003. Okay, so at least here we have a two-line fashion. Okay, next. What is the purpose anyways why we're doing this kind? Well, firstly, it's fast, and seldom in our conventional way of doing mathematics we have what we call partial products. In the partial products, most cases, we, as human beings, we're not perfect. We seldom have some overlooks in that partial products, and seldom those partial products will tend to will get confused in those parts. So it's better to eliminate them as much as possible. So next, 49 times 15. So 4 times 1 is 4. 4 times 5 is 20. Add that to the product of 9 times 1, which is 9. So we have 29. And then 9 times 5 is 45. Okay, fix the carry. So we have 4 plus 2 is 6, but we have a 13 here. So that's going to become 735. All right. Next, 38 times 32. So we have 3 times 3 is 9. 3 times 2 is 6. Add that to the product of 3 times 8, which is 24. And then that becomes 30, right? So we have 3, 0, and 8 times 2 is 16. So let's fix that. This becomes 12. 0 plus 1 is 1, and then 6. So 1,216. Though, we want to emphasize as well that we can do this from right to left if you really want to have the calculations from right to left. So we just want to emphasize that we can still do it. We just need to make this as our step 1 instead. This will be step 2 and this will be step 3. But anyways, it will still yield us the same number of steps, the same rigor, and the same routine. Okay, so let's try it here. 91 times 75. So let's do it from right to left. 1 times 5 is 5. 9 times 5 is going to give us 45. You add that to the product of 7 times 1, which is 7. That's going to give us 52, pretty much. And then 9 times 7 is 63. So what we have is we're going to carry this 5 and 5 here to 63. That's going to give us, I think I need to put it here, 6, 8, 25. And that's the product of 91 times 75. Okay, here let's have it 45 times 81. Let's do it from right to left this time. 5 times 1 is 5. 4 times 1 is 4. You add that to the product of 8 times 5, which is 40. So we have 44. We're going to put the 4 here as a carry. 4 here will be on the tens digit. And 8 times 4 is, it's going to give us what, 32. Fix the carries. So we have 3,600, sorry, 3,645. Okay, so again, we want to emphasize that we can do it from left to right as much as right to left. Okay, with the same number of steps, and there's no change in the number of steps. It's still gonna give us a fast way to do the multiplications. Now, what I'm gonna do is I'm gonna give you a practice this time. So you are to perform the indicated operations. It depends on you whether you want to do it from left to right or right to left. And I'll be giving you 1 minute and 30 seconds to do so. So let the timer begin. Okay, hopefully you're in the middle of number 1 already. Hopefully you're in number 2 now. Okay, hopefully you are in number 3 and we still have around 23 seconds left. Okay, so here we go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right. So we have our time then, and let's try to check the answers. The answers are as follows. So for number 1, 67 times 52, it's 3484. Let us present it quickly. So 67 times 52 vertically. I'm going to do it from left to right, right? So we have 6 times 5 is 30. 6 times 2 is 12. Add that to the product of 7 times 5, which is 35, which will give us 47. And then 7 times 2 is 14. So what we have is 3484, which is exactly the answer right here for number 2. So let's have 42 times 34. Let's have that from left to right, crosswise, vertically. 4 times 3 is 12. 4 times 4 is 16. Multiply it here. 2 times 3 is 6. So we have 22. And then we have it crosswise multiplication. 2 times 4 is 8. So fix them. We have 1, 4, 2, 8, which is number 2 right here. And for number 3, 39 times 32. So what we have is 3 times 3 is 9. We have 3 times 2 is 6. Add that to the product of 3 times 9, which is 27. And then that's going to be 33. And then we know that 9 times 2 is 18. Carry the 1, right? The 8. So what we have is 1, 2, 4, 8, which is the answer right here. Okay, so I hope you got at least 2 out of 3. If you only got 1, so more practice will be necessary. All right, now let's continue with 1 point from 1.1 to 1.2. We're going to extend this into 3-digit multiplication. So we have 3 digits now. We're going to multiply 3 digits by 3 digits. So let's see. First step will be crosswise, or rather vertical multiplication. We're going to multiply the hundreds place by the hundreds place. That's going to be our first digit on the left side. And then crosswise multiplication starts here. We multiply the hundreds place of the first number by the tens place of the second number. Add that to the product of the tens place of the first number and the hundreds place of the second number. That's going to be our second solution. Next, we're going to crosswise all the way, multiply the hundreds place of the first digit by the ones place or ones digit of the first one. Add that to the product of the 2 tens digits. Add that to the product of the ones digit of the first number and the hundreds place of the second number. And then that's going to be our third number. It's going to be usually it needs a lot of carry right there. And for step 4, we're going to multiply the tens digit of the first number by the ones digit of the second number. Add that to the product of the first number. The first number's ones digit and the second number's tens digit. And then lastly, vertically multiply the ones digit by the ones digit. Now, it may sound and it may seem like to be a tedious step to do, but with much practice, it will be, believe me, it's going to be faster compared to the blanket method. So let's have our first example. Let's have it 3, 4, 2. I think I'm going to need some space. 3, 4, 2 times 1, 3, 4. Well, let's multiply that. So first step, 3 times 1 is 3. Second step, crosswise. 3 times 3 is 9. 9 plus the product of 4 times 1 is 4. So 9 plus 4 is gonna give us 13. It's gonna be something here. And then the step 3, 3 times 4 is gonna give us 12, plus the product of 4 times 3, which is also 12, plus the product of 1 times 2, which is 2. So this is gonna give us 26. 2, 6. And then crosswise here, 4 times 4 is 16, plus the product of 2 times 3, which is 6. So we have 22. So we're going to put here 22 right here. And then 4 times 2 is going to give us 8. Sum them all up. We have 4, 5, 8, 2, 8. And everybody, this is our answer for multiplying 342 by 134. So this is much a faster way with much practice compared to the blanket method, which is composed of, um, a lot of steps, a lot of partial products for sure. More example, let's have this one. 504 multiply it by 321. For sure, it will be quite easy because we have 1 0 here. So, by zero property of multiplication, it will become 0. 5 times 3 is 15, put that down, step 1. Step 2, 5 times 2 is 10, plus the product of 0 times 3. So that's going to become 0. So that's simply 10. Next is 5 times 1 is 5, 0 times 2 is 0, 4 times 3 is 12. So basically it's 12 plus 5. So that's going to give us 17. And then 0 times 1 is 0, 2 times 4 is 8, and then 4 times 1 is 4. Bring down the necessary, or sum up the necessary things. 1, 6, 1, 7, 8, 4. And that is our answer for 504 times 321. So basically, it's quite easy without the partial products. It's much cleaner to see. So this is our practice 5.3. Multiply. It's your time to shine. Multiply 413 by 523, please. So I'm going to give you 1 minute again and 30 seconds. Go. Hopefully you're now in step 2. I know it's quite challenging, but step 3 is indeed challenging. So hopefully you'll be careful there. I can see maybe some are already in step 4 or step 5, and some are already summing up and clearing the answers. Okay, so together 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Here we go. So this is our answer. That's 215,999. So to show how is that our answer, hopefully most of you got it and got the correct answer. So let's have it. Sorry, that's 2. So step 1, 4 times 5 is 20. Step 2, crosswise, 4 times 2 is 8, plus 5 times 1, which is 5. So we have 13. Next, step 3, 4 times 3 is 12, plus 2 times 1 is 2, plus 5 times 3 is 15. So that's going to give us what? 29. And then step 4, 1 times 3 is 3, 2 times 3 is 6. That's going to give us 9. And then 9 times 9 is going to give us 9. So therefore, what we have is 2, 1, 5, and then 9, 9, 9. And that's pretty much our answer here. Okay, now to the next part in 1.3, we'll be extending the concept. We'll be extending the sutra, making use of multiplication of digits, of 4-digit numbers. So I'm not going to give some examples, but let's see if you got the pattern of the sutra vertically and crosswise. So let's have step one. I'll call it S1 here. So step one, if we have 4 digits right here, I'm going to make it as much as possible. Let's fit it in our screen. Step one will be there, the vertical method. Okay, step two, let's imagine 4 digits right here. It's now the start of the crosswise. So we cross this, the thousands to hundreds and thousands to hundreds. That's their step two. Step three, similar to, you know, the 3 by 3, we multiply the thousands to the tenths, hundreds to hundreds, tenths to thousands. That's our step three. Step four is where it's going to be quite interesting because it involves all the digits in the two numbers, thousands to ones, hundreds to tenths, tenths to hundreds, and ones to thousands. That's your step four. Step five will be it's similar to step three. So hundreds to ones, tens to tenths, ones to hundreds. Step six, it's going to be similar to step two. So we have tens to ones, ones to tenths, and then step seven will be the last one, which is our vertical step, the last step, ones to ones. So notice, I hope you see the pattern here, though I would imagine it should have been bigger. But anyways, thousands to thousands, step two is here, step 3, 4, 5, 6, 7. So that's our vertical and crosswise multiplication. Okay, now making use of this, we can extend the pattern actually and apply it in what we call algebraic products, in algebraic expressions. The vertically and crosswise method or sutra of multiplication described and shown before can also be applied to multiply polynomials in one single line. So for example, expand 2x minus 4 times 3x minus 5. So let's write it first like this. 2x plus 4 times 3x minus 5. So first, vertically, 2x times 3x is going to give us 6x squared. Now, crosswise method, 2x times negative 5 is going to give us negative 10x. Add that to the product of 4 times 3x, which is 12x. So 12x plus negative 10x is going to give us positive 2x. And then vertically, positive 4 times negative 5 is negative 20. Now, this is our trinomial after multiplying this binomial here. Okay, and this is actually correct. Take a look at it. It's a one-line method, everybody. A one-line method in algebraic products. Now, how do this work? So let me explain some bits why it works. There is an important principle which has a harmonizing effect relating to algebra and arithmetic. By the substitution of x equals 10, we can turn an algebraic expression into a number and, you know, a number into an algebraic expression. So for example, we may take a look at 652 and treat all the x's to be 10. We can rewrite this into an algebraic expression in the form of 2x squared plus 5x plus 2. So if we're going to let x to be 10, so this will be this, and that will be 652 still. Hence, that's why our vertical and crosswise method reaches algebra because of this principle. And, you know, it can be applied in both algebra and arithmetic. So having that in mind, let's have this example. So expand x plus 3 times x plus 7. So let's write x plus 3 times x plus 7. What we have is vertically, that's x squared. Crosswise, x times 7 is 7x plus 3 times x is 3x. That's going to give us 10x plus 10x. And then 3 times 7 is 21. So that's our answer, x squared plus 10x plus 21. Here on the second example, so we have 3x plus y times 4x minus y. So what would be our product? So vertically, 3x times 4x is going to give us 12x squared. Crosswise, 3x times negative y is going to give us negative 3xy. And then add that to the product of 4x times y. That's going to give us 4xy. So 4xy plus negative 3xy is going to give us plus xy or plus 1xy. We can hide the 1. And then y times negative y is going to give us negative y squared. And that's our answer for that second number. More examples, shall we? So 5x minus 1 times 2x plus 3. So let's do it vertically. 5x times 2x is going to give us 10x squared. 5x times 3 is going to give us 15x. Add that to the product of negative 1 times 2x. So that's going to be negative 2x. What we have is plus 13x. And then negative 1 times 3 is going to be negative 3. And this is our product of 5x minus 1 times 2x plus 3. Next is, let's have this one, expand this. 5x minus 4y times 3y minus 2x. Let's have it. So 5x times 3y, that's going to be vertical. So we have 15xy. 5x times negative 2x is going to give us, that's going to be negative 10x squared. And then add that to the product of 4y times 3y. So that's going to be negative 12y squared. Now notice, we cannot add these two, okay? Since they are of different signs. So they are of different terms rather. So we cannot add them, we just simply need to copy it. So we have negative 10x squared minus 12y squared. And then vertically, negative 4y times negative 2x is going to give us positive 8xy. Now notice we have an error here. Not really an error, but it will make the vertical and crosswise method longer. The thing is, we should have the like terms on a single column of our operation. So notice here, all the x's which are like terms are of diagonally. They are not in a single column, just like this one. So to fix this error, we should put them first in a single column. So let's write 5x over here minus 4y. And let us change the second number into negative 2x plus 3y. So if we do that, we could actually make the computations much easier. 5x times negative 2x is going to give us negative 10x squared. Crosswise, 5x times 3y is going to give us 15xy. Add that to the product of 4y minus negative 4y times negative 2x. So that's going to give us positive 8xy. So 8xy plus 15xy is going to give us 23xy. And then negative 4y times 3y is going to give us negative 12y squared. So this answer is actually practically the same with this if we're going to add 15 and 8y. But take a look at this. This is in a one-line fashion. So this is much better compared to the one before. So again, if like terms are on separate columns, try to make them first in a single column and then proceed with the multiplication. Okay, let's have this exercise and I will give you time to answer this. Time starts now. Okay, hopefully you're now on number 2. Okay, 30 seconds left. You should be on number 3 right now. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Here we go. And the answers are as follows. Okay, so for number 1, we have 6x squared plus 19x plus 15. For number 2, 3x squared plus 19x minus 14. And for number 3, we have 15x squared plus 23x plus 4. So hopefully at least you got 2 out of 3. So if you want to answer this, so we have 2x for number 1, 2x plus 3 times 3x plus 5. So vertically, we have 6x squared. Crosswise, 2x times 5 is 10x. And then add that to the product of 3 times 3x, so that's 9x. So we have plus 19x. And then 3 times 5 is going to give us 15. So that's our answer for number 1, which pretty much is the same. For number 2, we have 3x minus 2 times x plus 7. So we multiply vertically first, 3x squared. Crosswise, 3x times 20 times 7 rather is 21x. Add that to the product of negative 2 times x, and that's going to give us negative 2x. So get the sum, that's going to give us positive 19x. Now vertical again, negative 2 times 7 is going to give us negative 14. That's our answer for number 2. And lastly, for number 3, we have, I'll put it here, 5x plus 1 times 3x plus 4. So we multiply 5x times 3x, that's going to give us 15x squared vertically. Crosswise, 5x times 4 is 20x. And then crosswise again, add that to 1 times 3x, that's 3x. So what we have is 23x. And then 1 times 4 is 4. And that's our answer for this number 3. Okay, now before we totally say goodbye to these exercises, I want to emphasize that in the numbers, going back there, we can do it from left to right and right to left. We want to emphasize though that when we're doing it in algebraic products, it's much better and cleaner if we're going to strictly do it from left to right. Okay, now we can also apply this to trinomials and beyond. So let's have one example of trinomials and let's get on to it. So for example, we have 1 plus 7 plus x squared times 2 plus 3x plus 9x squared. So again, we're going to make use of the same pattern that we have. Vertically, 1 times 2 is 2. Crosswise, 1 times 3x is 3x. Add that to the product of x times 2, which is 2x. So what we have is plus 5x. Now the crosswise method, which spans all the numbers, 1 times 9x squared is 9x squared. X times 3x is 3x squared. And x squared times 2 is 2x squared. So 9x squared plus 3x squared plus 5x squared, add the coefficients, that's going to give us 14x squared. Plus crosswise again, 9x squared times x is going to give us 9x cubed plus the sum of plus the product of 3x times x squared, that's going to give us 3x cubed. So that's going to give us 12x cubed all. And then lastly, vertically, x squared times 9x squared is going to give us 9x to the 4th. So that is our answer. 2 plus 5x plus 14x squared plus 12x cubed plus 9x to the 4th. Now that is one line, everybody. Okay, we don't need to have different lines. We don't really much to specifically write down the FOIL methods and stuff, but this will give us a straight one-line fashion for finding the algebraic products. These things that I'm writing at the end, when you get used to it, you don't need to write this specifically. So that's the end of my presentation. That's the one of the applications of Vedic mathematics, which is vertically and crosswise multiplication. So I hope you learned something from this presentation, and you can reach me through this different sites. So LinkedIn, I'm there, Facebook, YouTube. I have a channel, through my email address if you have some questions, and through my researches in ResearchGate and in my ORCID. So thank you very much for having me.